This video is about one-to-one functions. We had in theme 5, under the heading of linear equations, we discussed what is a function. And there we said a function is defined such that for each x value there is only one y value. But in this case now, we need one-to-one function. What does that mean? First of all, to test whether something is a function, we use the vertical line test. But for a one-to-one function, we need more. If we at all interested in getting the inverse of the function, we first need a one-to-one function. So when do we have a one-to-one function? We have a one-to-one function when we first of all have a function. That means each x value has only one y value. But now each y value must have only one x value. So we also call it injective, an injective function. I did not use the word at all in my notes here, but it's an injective function. So when x has only one y value and y has only one x value, then we have a one-to-one function. So in this case, once we know it's a function, then we test whether it's one-to-one by doing a horizontal line test as well. So you go with a horizontal line from top to bottom over this function, and if it only cuts the function once, then you know that each y value also have only one x value. Algebraically, there are two ways to write this. So to know whether a function is one-to-one, we take two y values which are equal, and then if that implies that the x values are also equal, then I know this is a one-to-one function. Also, if I take two unequal x values, then it must imply that the y values are also unequal. So there are two different ways to determine whether, or three different ways. Graphically, horizontal line, either this number 1 or number 2 that you can use to find out whether a function is injective or whether it's a one-to-one function. First of all, here we have the straight line y equal to 3x minus 2. We can easily see it's a function. We know straight lines are function. But if I now take a horizontal line, it will only cut the graph once. So a horizontal line cuts the graph once for each y value. I see I already typed it here. Algebraically, if I now take p of x1 equal to p of x2, then it means that when 3 of x1 minus 2 is equal to 3 of x2 minus 2. Remember, it must be true in general. We can't just have two specific values where it holds. It must hold for each x value and each y value. So now I can just add to both sides. Then I get 3x1 is equal to 3x2. And if I now divide by 3 both sides, then I get x1 is equal to x2. That means that if I start with two equal y values, then the x values are also equal. All straight lines are one-to-one functions except vertical lines, which is not a function anyway, or horizontal lines. So for horizontal lines, for one y value, I will have many x values. So we exclude those two, the vertical and horizontal lines. On the left-hand side, this graph is the graph of the function y equal to x squared. Y equal to x squared, our mother graph. And I've drawn a red horizontal line at y equal to 4. So we see it cuts at two values, so we will get two x values, in which case we will have -2 and +2. So in this case we have x1 equal to -2 is unequal to x2, which is equal to 2. But f of x1, which is f of -2, is equal to 4, and f of x2 is equal to f of 2, which is also 4. So that means that even if I start with different x values, it doesn't imply that the function values are different. These two are equal to each other. F of -2 is equal to f of 2. So most definitely the parabola is not a one-to-one function, but can be used part of this function. We saw that for f of x equal to x squared, we do not have a one-to-one function, but we can restrict the domain to x greater or equal to 0, so then we only have the right-hand side of the graph. Or we can have the left-hand side of the graph. Then we can see that a horizontal line will cut the graph only once. And in this case, we will have a one-to-one function. In general, we can also say that if a function is only increasing or if a function is only decreasing, in this case, this function is only increasing because as x get larger, the y also get larger, then we will have a one-to-one function. If we look at the previous one, y equal to x squared, we have first a decreasing function and then an increasing function. So we can have the left-hand side here, ignore the right-hand side, and have an injective function or a one-to-one function, or we can look at the right-hand side like in this example. If we look at a simple hyperbola like 1 over x, first of all, we know it's a function because each vertical line will cut the graph once. Even here at the asymptote x equal to 0, it looks as if the graph is vertical there, but it still has a slope, just a very large slope. And we can see then that a horizontal line will also cut it only once. So if I have g of x1 equal to g of x2, then we can see that 1 over x1 is equal to 1 over x2. But that can only happen when x1 is equal to x2. If the y values are equal, then the x values will be equal. And we only need the one direction. We only need to choose two y values that are equal and then prove that the x values are also equal. We don't need the other side. So g of x, which is hyperbola in this case, is a one-to-one function, and so are all the rectangular hyperbolas. If we now look at the simple exponential function, and we know that all the exponential functions look like this, we do have the other one that is the mirror image that goes down like this, y equal to 2 to the minus x. We do have that also, and it has a smooth curve like that one. Both of them are one-to-one function because horizontal line will cut the graph only once. And in this case, if we look at h of x1 equal to h of x2, then we will have 2 to the x1 is equal to 2 to the x2. According to our laws for exponents, we will then have x1 equal to x2. So we can also say that if we start with equal y values, then we will get equal x values. So 2 to the x as well as 2 to the minus x, and all the family of exponential functions will be one-to-one functions. So let us look at semicircles. Here I've written down the equation of a semicircle with radius 2. Remember we said there's a little plus there, which we do not write. And I can pick any values. The easiest values that we can easily read off is here at x equal to minus 2 and x equal to plus 2. So if I put x1 equal to minus 2, which is unequal to 2, which we choose to be x2, then f of x1 is f of minus 2, which is equal to 0, but that is equal to f of plus 2, which is f of x2. So that means I have the two different x values, but it does not imply that the y values are different because we have two equal y values. So this is a counterexample that tells us that the graph will not be one-to-one. All semicircles are not one-to-one, and circles most definitely are not even functions. Again, we can restrict this graph by only looking at the positive side there from x0 to x equal to 2, or from the negative side from minus 2 to 0, and then both of the quarter circles will be one-to-one functions. You will encounter many inverse functions in first year mathematics, like the arcsine and arctan and arccos functions, where we will specifically concentrate on a part of the function that is strictly increasing or strictly decreasing, and then get the formula for that or the graph of that. So you can look at other examples and see whether you can either do it algebraically like that or graphically by using the vertical line test for functions and a horizontal line test for one-to-one functions.